All right, let's get this statement and get started because we have a lot to do. We need to keep following ahead. So it looks like Liz over here. Uh-oh, where's Elena? Here. What? Okay.
I first. Well, I have religion. Okay, second. I feel like you need to change your schedule back. Yeah, so we can. Maybe I'll take classes.
All right, so I think we need to finish up our review, and then we need to start 214. So let's see, I think we're ready for number 5 on the review. The big review I did, right? We're doing another sheet of paper, and we are evaluating these things. We didn't do this already, right? All right, so let's hear some ideas. What do you think about, these are just basic problems. These are nothing hard, these are just the basics. So what do you think about that first one? So if you have an exponent, a coefficient out in front, that becomes an exponent. And so this is ln root e squared, and of course root e squared is e, and ln e is 1. Now I want to talk about this for a quick minute because you have been programmed, I hope, to cancel ln and e, right? When you have an ln and an e, but they have to be actually touching each other. So these won't cancel. All right, because there's something in between them. You could fix that. What's another way of writing that radical? E to the 1/2. Yep, that's right. Now they are touching each other, so those would cancel. I'm leaving you with 1/2 times 2, which is 1. So don't cancel these guys unless they are physically touching each other. And you can make that happen with this. All right, what about this? What's log base 6 of 1? 0, absolutely. And if nothing else, you guys, if you can't, I mean, you should know that already because of the way the logarithmic curve looks, right? You take the log of 1, you get 0 no matter what the base is. But if push comes to shove, you can set this equal to x, and then loop-de-loo-it, right? So clearly the answer is 0. All right, what about this one? I heard somebody say -2, and that is exactly right, because if you raise 1/7 to the -2nd, that would be the same as 7 squared, which is 49. When your exponent is negative, you're 1 over. Right? Basic things, guys. We gotta know this stuff. All right, how about D? I'm not even gonna write it down. What's the answer to D? No solution, because you can't take the logarithm of a negative. Again, go back to your original BFF. There's no picture over here for a logarithm. X can't be negative, you can't log it. All right, how about E? 3. You can do that one of 2 ways. One is you can just recognize that the log base 7 of 7 is 1 times 3. Or you can move that 3 up to an exponent and have the log base 7 of 7 cubed, which is 3. How about this one? The log of 1 over 100. What? -2, absolutely. Remember, the base on that log is 10. Since it's 1 over, you know your exponent has to be negative. Since 100 is 10 squared, it must be -2. 10 to the -2nd is 100. Okay, what about this next one? A little bit trickier. What are you going to do with that guy?
Get base 2.
You can, I heard somebody say change the base, I heard somebody else say loop-de-loop. I would probably, personally, loop-de-loop first. So 16 to some power is 8. And then I would recognize that both of these are powers of 2. So 2 to the 4x equals 2 cubed. 4x equals 3 and x equals 3/4. Now, as long as you're coming up with 3/4 and you're doing it without a calculator, it's good, it's all good. You don't have to do it exactly the way I'm doing it. Okay, what about this one? Again, you've got some options, how you think about it, but what's the answer? Tell me what you think the answer is, and we'll talk about how you got it. -4. You can get that, first of all, if you just do this. What's that? 2 times -2. Or you can move this up into exponent area, and clearly the answer to that is -4. What's the log base 4 of 0? Kids, no, I don't know why you're all just sitting there staring at me. Can you raise 4 to a power and get 0? Is that possible? No, there's no solution. There's an asymptote at 0. You cannot take the logarithm of 0 because that won't work. Any base, that won't work. And finally, throw out an answer to that, and then we'll talk about how you got it. Because again, you've got some options. What do you think?
-6.
What?
-6.
So Lola says she thinks the answer is -6. How'd you get that, Lola?
Let's see. I put the -2 up to 27.
Okay,
And then
so
I
you
did,
move that up to an exponent, okay.
and then I did 3x equals -27.
So she looped.
And then I made the 27 to 3 in times the exponent.
Beautiful. That will absolutely work. That will absolutely work every time. You could also look at this part of the problem right here. That's the log base 3 of 3 cubed, which is 3 times -2, and get -6 that way also. All right, turn it over. And now we're going to look at a whole bunch of stuff here with respect to this one equation. What is a little bit different about this equation? Does anybody notice anything that's at all different about it? Jamie?
The base of the log is
Okay, the base is less than 1. Now, I want you to think about what you know about exponentials. Is there a difference when the base is bigger than 1 and when the base is less than 1? Does that cause a difference in the picture? Yes, it goes from growth to decay, right? In other words, it flips it across, that's what this one looks like, and this one looks like this. So it's a reflection across the y-axis, right? Now let's see if we can think about this. I know it's the first day of the week, I know it's freezing cold out, but what's the relationship between logarithms and exponents? They're inverses. Remember when you find the inverse of an exponential, it's a logarithm equation and vice versa? They're inverses. So if I make the base less than 1 in an exponent, and it reflects it across y, what's gonna happen when I make the base less than 1 in a logarithm? Reflect it across x. So a normal logarithm, we know, looks like this. If the base is less than 1, it's gonna look like this. Okay, now, tell me, so that's gonna be the general shape of this thing. Now, what else do we know about it? Tell me what else I know. I have the general shape now in my mind. What else do I know though about this? Asymptote is gonna be at x equals -3, which means that my intercept is going to be at -2. I just erased it, but remember the normal intercept is just 1 to the right. And then I know that it has this general shape because the base is less than 1. Okay, let's answer questions. Would you say this thing is increasing or decreasing? Decreasing. Remember, you make that determination by asking yourself, as I move left to right, which way is my pencil going? Now, I know there's an arrow there, but to get that arrow, wouldn't I have to go right to left? I have to go this way. I have to go left to right. So that is decreasing. Does it have an asymptote? Yes, it does, and it's at x equals -3. Concave up or down? Up. Remember, logarithms are always either concave up or concave down, just like exponentials. Does it have an x-intercept? Yes, it does, at -2. What is its domain? -3 to infinity, and remember, -3 isn't counted because it's an asymptote. How about its range? -infinity to infinity. And end behavior, we talked about this a little bit the other day. For a logarithm, well, first of all, for end behavior, we are programmed to start this way. That is end behavior. What happens all the way to the right, what happens all the way to the left. But with logarithms, we have to modify that because why? They can't go all the way to the left. So instead of saying -infinity, we're going to say -3. And if you want to be like really on top of things, put a plus there because we're actually approaching it from the right side. All right, so tell me, what happens as I go all the way to the right? The limit as x approaches infinity. -infinity, that's going down. And how about as I approach my asymptote? Positive infinity. Okay, we all right with that?
How did we find the x-intercept again?
It's always what, think about what your basic logarithm looks like. Asymptote's at 0, 1 unit to the right. Okay. All right, I want to throw a couple problems up here just to make sure that we are on target, and then we've got to move on to our notes a little bit. So let's try this one. I don't think I've done this one yet. I haven't done that problem. I don't think I have. Okay, so Alex says that because there's an addition here, log plus log, we're gonna end up multiplying those, so we're gonna have 4x minus 12. How's that? Is that all right? Now what? So if this log is less than that log, then that automatically means this has to be less than this. And so 2x is less than 5, and x is less than 5 halves, is that right? Bless you. Is that the answer to the question though? Why not? Because in a logarithm problem, I have to consider domain, right? Right? So what does this tell me? Right here, that tells me what? X has to be bigger than 3. We'll stop right there, we have a problem. Because what did you just tell me X was? Less than 2.5? Can I be less than 2.5 and bigger than 3? No, this problem has no answer. Now, also X would have to be bigger than 7 halves, but that doesn't work either. I mean, none of this works. Right? You gotta think about domain every time you do a logarithm problem. All right, can you do a simple, quick little sketch of this guy for me? First of all, we haven't moved our x. There's no horizontal translation. So would you agree my asymptote's at 0 and my intercept's at 1? Just like normal. Now the question becomes, I have 2 options. I'm either going to graph it like a normal logarithm, or I'm going to graph it like one like I just graphed an upside down logarithm. Now what does that do right there? What does that guy right there do? He turns it over, right? But what does that do? Turns it over. So this ends up looking like a regular, normal logarithm. And finally, I may have done this one the other day with you guys, I can't remember. But anyway, we're gonna do it again. All right, solving for x, a little exponential. What are we gonna do? These two right here need to be combined. And they're gonna be combined by doing what to the exponents? Adding them. If that had been a 9, we would do the same thing, only we would make it 3 squared. And then add the exponent. So then we can, I got 526. Okay? All right, so we've had tons and tons of review for this mini quiz, which will take half hour tomorrow, half hour. All right, now now we're moving on, we got to be, gotta do a little bit of 214, 215, then we'll have a bigger test, quiz, whatever, a big one over next year. Over it next year. All right, so now we are looking at our notes, 2.14. Nothing really shattering here. But I do want to make a point. The first point is a review. It's in his little box there that he's got. And we talked about this a long time ago, like way back in December, that if your data is logarithmic, think of a table of values. If the data is logarithmic, the x's are proportional and the y's are linear. Okay, that's how you know it's a logarithmic set of data. Well, in example 1, they've only given us 2 data points, so it's hard, I can't tell from the 2 points, but they tell me that it's logarithmic. On your exam, you had a question like this. It wasn't logarithmic regression, but it was a different kind of regression, and some of you missed points. It was your big free response, and some of you missed points because you didn't do it the directions said. There are different ways to find your equation, but they're telling you specifically, use the given data to write 2 equations that then we're going to solve to find A and B. We're writing an equation that looks like this. Oh wait, A plus. The format they want us to use is this right here. All right, so what are my 2 equations going to look like using this set of data? 3 equals A plus B ln 2, and 7 equals A plus B ln 5. Everybody good with that? Now we could use logarithmic regression on our calculator and not mess around with this. But we're told this is how we're doing the problem. And we'll do logarithmic regression to check our answer. But we're doing this without regression on our calculator. So the first thing we did was build our 2 equations. Now, how am I going to solve for A and B? What would you suggest? We're here now. What would you suggest maybe we do? Substitution. In other words, I know that A equals 3 minus B ln 2, and A equals 7 minus B ln 5. Would you agree with that? So they're equal to each other. 3 minus B ln 2 has to equal 7 minus B ln 5. Okay, now what? We're solving for B, right? So let's get those B's on the same side of the equation. So I'm going to move my B ln 5 over here and my 3 over here. So I added B ln 5 and subtracted 3. Now what? Remember, I'm solving for B. What do I need to do? Take out a B. You're on fire today. You don't look like you are, but you are. Good job. You okay?
Yeah.
So B ln 5 minus ln 2 equals 4. So B is going going to equal 4 over ln 5 minus ln 2. Now, I definitely need a calculator, but I'm not using my calculator for regression. I'm using my calculator for arithmetic. This problem we're not doing with regression. So I can go ahead and type that in. 4 divided by ln. And if I did it right, I got 4.3654. I would love to have somebody confirm that. Okay. Now, how do I find A? Remember, I'm trying to build that equation. So I got my B, now I have to build my equation. So how do I find my A? Right over here? Yeah. So did you get negative 0.0259? So our equation is negative 0.0259 plus 4.3654 ln x. All right, let's check that on our calculator. So do you remember how to do that? I'm going to put in those 2 data points. And then what? What do we do once we get our data in there? We go back to stat calc. And we're going to choose logarithmic. And let's compare our answer. Did we get exactly the same answer? We sure did. We surely did. All right, let's turn the page and let's look at example 2. All right, here we go. This one we're using the regression capabilities of our calculator. So what are we going to do here? Stat, edit, and we're going to put all this in. So go ahead. Everybody should be participating. Sometimes we have to do things we don't want to do. He has to have his own. He doesn't get to be a good bowler by watching someone else bowl. He has to do it himself. CVS on the way.
Yeah, well, I got batteries last night.
Oh, okay. You didn't put them in? Oh, that's even worse.
Siege and I got this, negative 91.542 plus 29.999 LNX. Anybody else get that? Look good? Using the model, what is the predicted annual salary in thousands of dollars for a pastor whose church size is 500 people? So what do? Get Y. And we put in 500. Did you get 94.33 basically? 94.3295. Which would be $94,329.50 if we wrote it out as a dollar amount. You good? All right, let's do example 3, and then maybe we can review a couple more problems. Let's do example 3. So read through it, and you guys, you and your partners, see if you can figure out what's going on. Be sure to pay attention to the directions. missing something? Did your equations look like this? What's that? What's the log of 1? 0. So doesn't that tell me that A is 120? And then remember, what's your base? The way they set up their equation, they used log, so our base is 10, right? Tell me about this right here. The 1 times part you don't even really need, because that doesn't change anything. What's the log base 10 of 10 to the negative 5th? Negative 5. So isn't that equation just 70 equals A minus 5B? But we already know A is 120. So 70 equals 120 minus 5B. Did you get negative 10? So what's our equation then? That worked out really nicely. Our equation is 120 plus 10 log I or log X. Wow, that was a lot easier than I thought it was going to be. What about you? Are you okay with that? We found A and B. The human eardrum can burst when sounds reach an intensity level of 10 to the 4th. According to the model above, what is the predicted number of decibels required to burst a human eardrum? So remember, this is your 10 to the 4th, right here. So we're gonna have 120 plus 10 log 10 to the 4th. Am I doing okay? Remembering that the base on this is 10. What's the log of 10 to the 4th? 4 times 1040, I'm getting 160 decibels. And we did that whole problem without a calculator. And the reason we could do it without a calculator is because we were in base 10 and our numbers were powers of 10. So we could do that. Good? All right. Let's do a couple more review problems. All right, here's a couple for us to do. So let's take a minute and work on those, and then maybe we will have somebody come up and do them on the board. that's what I got, same thing Kiernan did. Anybody have a question about that, finding the inverse? We talked about that earlier. If it's a logarithm, its inverse is gonna be an exponential, and vice versa, okay. How about the second one, do we have a volunteer to do that quickly, so we can get a couple more problems up here? Oh, my, someone step up here, thank you. What's the key to Jamie's problem? We need everything to be 3. And then this 9 that's floating around over here, she's made that 3 squared, but then to combine those, she's gonna add those exponents. And solve her inequality. She got x greater than 7/2. Which she'll write in interval notation because she's a pre-calculus student. So that would be 7/2, comma, infinity. Everybody good with that? Easy peasy. All right, let's try this. End behavior. Find the end behavior, write the end behavior for these 2 equations. Oh, wait a minute. Wrong. Started, you might have to make some changes to that. So on we go. I would suggest that you draw a picture. I mean, I don't know, you don't have to, I guess, but it helps me to kind of visualize it. So Aubrey's dropping in an asymptote at -1. That makes sense, doesn't it? And she's got her curve decreasing. Does that make sense? Yeah, because of the negative out in front. Her base is 5, so it would be normal, except the -3 turns it upside down. Notice she changed her left end behavior to not be negative infinity anymore. She changed it to be -1, because that's where our asymptote is. That looks really good to me. I'm good with that. What about the rest of you? Are you okay with that? All right, what's our exponential look like? Well, let's do it in pieces, don't get overwhelmed. What would an exponential with a base of 1/3 look like? Okay, so that would look like this. But what does that negative do? Flips it, so now it looks like this. Everybody follow that? So that's my picture. So to the left, I am going down. And what am I doing to the right? Getting closer to 0 from the bottom. Is that all right with everybody? Okay. So we can get one more there. I have no idea what's gonna happen here, I'm just looking this up. But let's see. That look? Anybody else get that? I'm not done, but does that look what, okay so far? Anybody match that? Anybody gets -5/13 for something? No?
My sign was flipped.
Oh, it should be, totally flipped, because I divided by -13, totally, thank you. Okay, now I'm good, so far, I mean, what do I have to think about though? I have to think about whatever's going on there, x has to be bigger than -2, and x has to be bigger than -1/2. So my answers, I gotta put all this together. I have to be that, and I have to be that, and I have to be that. So what am I? What's my answer gonna be? You got your number line. Here's -2, here's -1, here's -1/2. And what's that? I don't know, but it's not a half. So it would be like right here. And I have to be bigger than all of those things. So isn't that just my answer? Now, look at what would happen real quick. What if my original sign had been greater than or equal to? Then this would have been less than or equal to? And then what would my answer have been? Because this guy would now be pointing this way. So now my answer would have been just plus that tiny little space, bigger than -1/2 and less than -5/15. Okey-dokey. 30 minutes tomorrow, so I want you guys to come in with the attitude you're gonna work. Not pokey pokey.
What do we have